I'm continuing extensive tests of the Syqon tools Starless, Parallax, and Prism, this time on a deep field image that I've been making since last year. This image now has about 10 hours of integration and was shot through a Schmidt-Cassegrain telescope, the Celestron C8, a 203mm aperture telescope, beneath the extremely dark skies of the Canadian backwoods. The image shot with a Player 1 Aries M camera using ZWO LRGB filters. And if you want to see the full resolution, completely developed version of this deep field image, just pop over to the Sky Story Astrobin. The link is provided in the description. This image will provide our test subject for today. As in the previous video, I'm going to process this image 3 ways. Once with Syqon tools running Parallax first, their sharpening tool, then Prism, their denoising tool. Another time with Syqon tools running Prism first, and then Parallax, and then finally, a standard development using the RC Astro tools BlurXTerminator and NoiseXTerminator. I will not be testing star removal tools in this video. With deep field images like this, star removal of any kind tends to become confused because many of the galaxies we're looking at are so far distant, billions upon billions of light years away, that if star removal tools become aware of them at all, they are frequently mistaken for stars. Up till now, I have always included the RC Astro tools in my workflow, where they form the basis of sharpening and denoising, upon which non-destructive layer-based developing is then conducted. And then finally, fine adjustments to color, luminosity, and detail are made in Photolab. Once again, I'm going to test the Syqon tools against the RC Astro tools to see if they will replace the RC Astro tools as the foundation of my workflow. And from these tests, I hope to be able to give you an opinion of whether or not you should use the Syqon tools, and also, I hope the tests can help Syqon in developing their tools. They are working actively on them, updating them frequently, and are aiming to create something remarkable. You see before you the luminance master of the deep field region around NGC 6047, the same image that you saw a moment ago in the introduction. I have not stretched this image. The image is rendered visible by application of PixInsight screen transfer function, which applies a temporary high contrast histogram stretch to the image for viewing purposes. The image was stacked in PixInsight's weighted batch preprocessor, and this is the luminance master fresh off the stacker. No development of any kind has been done to this image. I'm going to develop this image by running Parallax first on it, and then Prism. I mentioned in my last video that Syqon tools have a flexible workflow and they tell you to experiment with every image to find the combination that works best. However, a little earlier in the tool's history, the normal way you went about stretching was to use Prism first and then Parallax. However, as I understand it, they've recently changed those recommendations, and with later updates to the application, they now recommend running Parallax first, the sharpener, and then Prism, the denoiser. But because they do recommend to experiment and test results with every image, I'm going to create an iteration where Prism has been run first, then Parallax, and then an iteration where Parallax has been run first, and then Prism. By the way, I've run multiple iterations already, applying both methodologies, trying to find the sweet spot. That is, the settings on Prism and Parallax that will define the most structure and deal with noise the best, and, if at all possible, lift the underlying signal from the noise floor as Syqon states it can do in its website. As you can see, with this iteration I'm running Parallax first and then Prism. Now, in running these tools, there's already a problem. I'll show it to you here. If you run Prism on an unstretched image, it's supposed to apply a temporary stretch to the image so that it can identify and remove noise and lift signal out of the noise floor. However, in every single iteration of Prism that I have run, and I mean literally every single one, not just with this subject, but nebulae and galaxies that I've also used Prism on, if I run Prism on an image that has not been at least slightly stretched, I get this, posterization. And the posterization is unremovable, which means no matter how much I dim the image and try to shallow out the light curve, which decreases contrast throughout the entire image, the posterization is there. I should tell the viewer at this point that I have run over 120 attempts to develop using Syqon tools on this deep field image, on nebulae, and on galaxies, and posterization always turns up if I attempt to run Prism on an unstretched image. So while I would like to have left this image alone and just run Parallax and Prism on the pure raw image in order to get a sense of the results, the only way I can even get a usable result is to run a little bit of a histogram stretch on the image and then run Prism, which you see me doing right here. When it's done, I'm going to pull up a fresh copy of the Deep Field Luminance Master and run Prism on the master first and then Parallax. And regardless in the change in the order of running the Syqon tools, when I ran Prism on this unstretched image, I again got posterization. So I have to run a little bit of histogram stretch first in order to be able to make Prism work, because the stretch that Prism applies to an image is useless. There's no other word for it, it's useless. So I've allowed Prism to run, and now I'm running Parallax. When it's completed, I'm going to pull up another copy of the Luminance Master and run the RC Astro tools on it in their predictable workflow pattern. BlurXTerminator first on the unstretched image, and then the NoiseXTerminator on the stretched image. Once they're done, I'll just line up all three images right beside each other so we can compare and contrast their outcomes. At this perspective, at a glance, these images look very similar. But what happens if we scroll in and take a closer look? Let's take a look at the objects up to the right. There are 3 galaxies in that area. Well, more than that actually, just 3 that are close enough to have some definition. 2 interacting galaxies lower left, and the third to the right. In the image on the left, where I ran Parallax first and then Prism, we seem to get the most detail. We have some definition in the wispy interacting galaxies, and we appear to be pulling in the arms of the galaxy up to the upper right. The Parallax and Prism developed image on the left appears to be outperforming the RC Astro image processed on the right. But if we look closer at the Syqon images, both of them, we can see that all 3 galaxies have an odd, spongy texture. This happened in every iteration in the Syqon images, which is to say, no matter what, every way that I tried to vary the settings in the Prism and Parallax tools, we still got the spongy texture in the galaxies. I believe the spongy appearance results from Prism's attempts to pull information from the noise floor. I don't think it's really pulling information. I think it's mistaking slight preponderances of information here and there, caused by simple random fluctuations of the atmosphere, causing there to be a little bit more light here in one place, a little bit more light there in the other place. And it's resulting in tiny areas of the image being overemphasized, creating this odd, spongy texture in the galaxies as Prism tries so hard to find a little more information in the noise floor. It resembles the crunchiness one would develop in an image if an unsharp mask were applied too heavily to it. If you saw my previous video where I tested the Syqon tools on the Dumbbell Nebula, you may recall the Syqon tools created dozens, perhaps as many as 100, odd little knots all throughout the core of the nebula, which I think is partly due to Prism's tendency to over-sharpen and Parallax's tendency to misinterpret. But this ultimately results in the Syqon tools mistaking odd fluctuations in information for objects. To compare and contrast, I'll pull the RC Astro image into view. At first, the RC Astro image on the right appears to not quite have as much information as the Syqon image on the left. The appearance of its interacting galaxies, lower left, and the face-on galaxy, upper right, appear to be smoother. But upon closer look, you can see the galaxies don't have that spongy appearance. The RC Astro software, I believe, is not making the mistake of overinterpreting minor fluctuations in the degree and quality of light or information on the sensor, fluctuations that were most likely caused by random movements of the atmosphere. Let's examine another area of the image. We're going to look at some extremely distant galaxies a few 100 million light years away, and some much more distant galaxies billions upon billions of light years away beyond. In the left image, where Syqon's Parallax was run first, we do appear to get the most detail. In the middle image, where Prism was run first, then Parallax, we appear to get a bit less detail. And in the rightmost image, where we use the RC Astro tools, we appear to get the least amount of detail. But once again, if we take a closer look at this, we see that all is not as it appears. The image developed the Parallax first, and then Prism is filled with errors. All throughout this deep field image, over and between those far distant galaxies, is what appears to be wisps of dust, like you would see in the wisps around integrated flux nebulae. Now, it may be true that the Syqon tools do not hallucinate, they do not invent things, that is. However, I conclude that they absolutely, frequently misinterpret, because it is mistaking the faint hints of far more distant galaxies halfway across the cosmos and beyond, for dust-like wisps. Let me pull over to the RC Astro image and show you. There are some stars in this image, some galaxies a few 100 million light years away in this image, and those very faint hazes about the size of stars but which do not resolve like stars, the RC Astro tools have correctly interpreted as extremely distant galaxies, on the order of billions of light years away. I have documented capture of images over 20 billion light years away that's halfway across the observable universe, and that's what those images are. Unfortunately, in the second Syqon image, where Prism was used first, then Parallax, we simply end up with a whole new set of problems. This time, the Syqon tools at least made fewer misinterpretations of those objects as wisps of dust. But for some reason, it darkened and obscured those extremely distant galaxies. Let me zoom out a little bit so that you can see the RC Astro image beside the second Syqon image. The Syqon image is on the left, and, to be fair, I love the additional appearance of detail that we see in the galaxy lower left. It absolutely appears as if there is more detail there, as compared to the RC Astro image, which was processed on the right. Whether this is accurate or not, I cannot confirm. However, I can confirm that this apparent sharpening of this galaxy comes at a significant cost. There are two extremely faint, remote galaxies in this image here. The left one you might not be able to see at all due to YouTube's compression and poor handling of dark areas. Unfortunately, in the Syqon process image where Prism was used first, they have been reduced to extremely faint, almost invisible wisps. In fact, YouTube's compression in dark areas might not allow you to see those extremely faint wisps at all. Also note that there are other extremely faint distant galaxies all throughout the image, readily visible in the image processed with RC Astro, that have been decreased in brightness in the Syqon processed image to the point that they are almost invisible. There are at least 18 such errors in this one tiny part of the image. And in some cases, the Syqon tools have removed the appearance of those extremely distant and faint objects entirely. In addition, there is the problem of this star down here. Notice in the image on the right, processed with the RC Astro tools, you see a star spike. This results from pinched optics. I was shooting with an SCT telescope and intentionally ran the heat a little high on the dew ring to create the pinched optics effect, because at the time I was testing strategies to address star spikes, which is a common issue with SCT telescopes if heat is applied too heavily to the corrector plate. It can also be a problem with refractor telescopes if their lenses are bound too tightly to the fuselage. The star spikes definitely show with the RC Astro tools. In fact, its penchant for sharpening up stars actually makes the spike show a little more strongly, though as I've demonstrated in previous videos, that's also easily edited out with some simple techniques. On the other hand, an oval star, which appears in the Syqon tools, is much more difficult to correct. And I have to confess, I was disappointed with how poorly Parallax handled that star. In fact, this is another case where Parallax introduced an error. You see, the star is optically correct, that is to say the star is round. Parallax misinterpreted the star spike as an oval star, or an oval something anyway, and presented the star that way. I'll demonstrate. Here's the original master, untouched by any RC Astro tools or Syqon tools, and here's that same star. As you can see, it's round in the image, maybe a slight bit of ovalness to it, but it's round. And you can see the star spike emerging from the upper left. The RC Astro tools nicely rounded this star, and the Syqon tools turned it into an oval, I think trying to compensate for that star spike. However, to be fair, if we look at the version of the image where Parallax was run first, that's the sharpening tool, and then Prism, the denoising tool, the star is better rounded. I'll show that image now. Here, the star is better rounded, though it's still not rounded as well as it is using the RC Astro's BlurXTerminator. Now, as the Syqon tools have been updated, they have changed their suggested workflow. They always suggest a flexible workflow and trying different workflows and different settings of the tools in various images to get the best results. But their general recommendation these days is to run Parallax first and then Prism, and that's what this image does. And while it does round out the star better, it introduces so many more errors into this image, I'm not even going to bother to count them. As we've already talked about, it converts those extremely distant deep field objects, which are by and large galaxies, halfway across the cosmos into wisps of dust that resemble wisps of IFN. And this image is so flawed, it's honestly just not worth counting the errors. The whole image here is a flaw. To be frank, I had examined a half dozen other places on this image in order to compare various versions of the Syqon workflow against RC Astro tools. But these exact same kind of errors are repeated in every place. Distant galactic structures are either minimalized, sometimes entirely removed from the image, or maybe that's not the best way to put it. Their brightness is rendered so dark that they don't show up, but it's tantamount to the same thing. Distant galaxies, as you see right here, appear spongy, or extremely distant objects in deep field images are misinterpreted as wisps. Wisps that resemble traces of perhaps reflection nebulae or integrated flux nebulae. So, unfortunately, once again in this case study, I just have to conclude that I honestly would not use any of the Syqon tools in my workflow. And I mean, I wouldn't use them in one application or another because I've experimented with all kinds of ways to make them work. At this point, I've run a little over 120 iterations or versions of tests, and I have found no cases where I would choose to use the Syqon tools. They may not hallucinate, but they create many, many errors and all kinds of images. And for deep field astrophotography, to be honest, this is useless. Maybe the tool just needs much more training on deep field images. I don't think too many astrophotographers are shooting deep field images, so that wouldn't surprise me at all, but as it stands right now, these tools are just unusable. Literally just yesterday I was processing a new image of a small, seldom shot reflection nebula near the North American Nebula, IC 5076. My goal has been to produce one of the most detailed images of this often neglected little reflection nebula that's ever been recorded before. Feel free to cross-check at Astrobin and elsewhere. In fact, if you know something better, I'd like to know. But I think I'm definitely moving toward that goal. I still need more integration on it. Right now, this image only has 9 hours of integration. If the weather will cooperate, and while this image is well positioned, I plan to shoot at least another 3 or 4 hours on it. But I did find a way to get Prism to help this image. However, when I tested Prism's ability to bring out a little more information against the method that I started teaching people years ago, by way of the process of separating the high and low frequency components and then drawing out more detail specifically from the high frequency components using a process I call synergistic sharpening, which can only be done with non-destructive layer-based editing, the results from frequency separation and synergistic sharpening came out to be much superior. So even though I was able to make Prism produce a slightly better image if it worked in conjunction with the RC Astro tools, mainly by adding a little more sharpness to the image, in the end, I was able to get better outcomes by leaving Syqon entirely out of the workflow and just using methods that I've been using for years. We'll probably go over those outcomes in an upcoming video too. However, I do want to do a well-rounded review. My goal is not to knock Syqon. I hope Syqon improves their tools. I really, really do. I would love to see them become something incredible. And to do this, we need to demonstrate their application to all subjects. So in the next video, we're going to take a look at using Syqon to process a galactic structure. Thank you for watching, and as always, if you have any thoughts or observations, please feel free to let me know in the comment section below. Have a blast doing astrophotography, learn something about the sky overhead every day, and always take a moment to look up, appreciate that universe out there, and get out there if you possibly can, and shoot the sky.